As we've already seen this function and we worked out how this function behaves with a finite limit, so we saw that when we had x to tend to positive infinity, you can see from the graph that the function f of x equals to 1 plus 3 e to the power of x divided by 1 plus e to the power of x. This tended to the line y equals to 3, which means that when we had x reaching infinity, and as x got higher and higher, the function got closer and closer and closer to the value of 3. And we also saw when we analyzed it for when x tends to negative infinity, this function had tended to the line y equals to 1, which you can see from the graph here. So which means that as x gets lower and lower and lower and closer to negative infinity, the function gets closer and closer, the graph of the function gets closer and closer to the line y equals to 1 and to the value of 1. So we've seen that by analysis and by analyzing the graph of the function. Now we're going to use algebraic manipulation to see how this limit actually works. So for example, if we are considering both the limits, where we have limit x tends to positive infinity first, and we have the function 1 plus 3 e to the power of x divided by 1 plus e to the power of x. And now we're going to see how this works. So let's consider for positive infinity first. So as you can see from here, I've already given out what answer we're supposed to expect. We're supposed to get the limiting value to approach 3. So now we're going to see how this limit can be solved. So imposing the limit, what we will have is 1 plus 3 e to the power of infinity divided by 1 plus e to the power of infinity. Now you can see that if we just keep the infinities, we know that e to the power of infinity will be infinite. And if we keep the limits of infinity in the numerator and the denominator, this will give us something that is an indeterminate form, which means we will get something like infinity by infinity, and which is something that we don't want. So what we have to do is we have to manipulate this algebraically and see how we can avoid this indeterminate form. So what I'm going to do is I'm going to divide both the numerator and the denominator by the expression e to the power of infinity. So what that will leave me with is e to the power of negative infinity plus 3 in the numerator and e to the power of negative infinity plus 1 in the denominator. So you can see from here that when I have e to the power of negative infinity, this simply means 1 by e to the power of infinity plus 3, and this also means 1 by e to the power of infinity plus 1. And we know that e to the power of infinity is infinite, and anything divided by something that is infinite will give us the lowest value possible. Since we're dividing by the highest value possible, this will give us the lowest value possible, as I've already shown before. So that means that this whole expression turns to the lowest value possible, which is 0. So I'm left with 0 plus 3 in the numerator and 0 plus 1 in the denominator. So what that just leaves me with is 3 by 1, which is equal to 3. So you can see that this exactly matches with the expected result that we were supposed to get. So now for the next limit, we have limit x tends to negative infinity, and we're evaluating this for the function 1 plus 3 e to the power of x divided by 1 plus e to the power of x. And now we know that the expected result we're supposed to get is positive 1. So now imposing the limit, we have 1 plus 3 e to the power of negative infinity divided by 1 plus e to the power of negative infinity. Now again, we can just write it like this: 3 divided by e to the power of infinity divided by 1 plus 1 by e to the power of infinity. Now again, given the same considerations, the same argument, we know that anything that is divided by something infinite, we know that that will give us the lowest value possible. So what we will be left with is 1 plus 0 in the numerator and 1 plus 0 in the denominator. So this just leaves us with 1 divided by 1, which is simply 1. And this is exactly what we expected to get. So you see how even graphically, when we analyze the graph of this function, we got the the value of the function approaching a finite value as x tended to either positive infinity or negative infinity. And also you can see that algebraically when we manipulated the function, we also got the limit to be the same thing.